Begin.
Good evening, ma'am.
Good evening, ma'am.
Good evening, ma'am. Yes, children. Good evening, everyone. Good evening, all of you.
Good evening, ma'am.
Yeah. Good evening, children. Good evening. All right, children. Today your seniors got marks, right? CBSE results got, right, children? Anyone here? Brothers are there in class 10, children? Yes, siblings are 10th class. Anyone in the class? I think Deepika is here. Deepika's sister Bhumika got 99 in 99 or 98, children, in mathematics, and science to 97 or 96 something. Our students scored more. Most of the kids scored more than 95. More than 95. 94, 95, 96, 97, and 98. These are the scores in math and science. Right, children, coming to the rest of the part. Which chapter we are doing? I think the probability we should start. We should start probability, right?
Yes, ma'am.
Okay, fine.
Yes,
children.
ma'am.
Right. We should start probability today. Nehal is our average student in lower classes, children. Class 7 onwards, I know Nehal. The boy very seriously attending all the classes and the regular tests, Sunday test he is doing. but not first in all the tests, but he is very regular to the classes, very responsible student. He is also scored very well in the recent 10th class board exams, children. That's why the students, not only hard work, regular way you need to present from basic classes, children, like class 7, class 8, class 9, class 10. These are the continuous pillars for your 10th class. Not only in class 10, we can, whatever the things you are anyway choosing the best institution, please focus regularly basic concepts because class 10 board is very easy paper, maths paper. When I'm only 1 or 2 questions are twisted, rest of the part is given directly. Only the thing, that twisted part, if you are able to do, you can get full score. Only there is 1 or 2 marks based on that twisting part only. Maybe our student, I'm expecting that maybe got go. That's why doubt session clarification of doubts is more important. And another thing is continuous practice, regular to the classes and the Sunday test. This all will help you, children. Right. Right, children. This is your probability chapter. It's more easy, only basic part only given. Yeah, chance and probability. Just a minute, children. Mute the things. There is a lot of disturbance. All right. What is probability? What is chance? You can see the basic things are the. Sometimes it happens that during rainy season, you carry raincoat every day and doesn't rain for many days. However, by chance, one day you forgot to take raincoat and it rains heavily on the day. It happens, yes or no, children? We all experience this example.
Yes, ma'am.
Yeah. Sometimes it happens that a student prepare 4 chapters out of 5 very well for the test. But major questions is asked from the chapter what she left. That's unprepared. Yeah, she left unprepared. So here, what is the probability of getting a good score here in this case, second case? Is it most likely or less likely? Suppose there are 5 chapters. A student prepared 4 chapters. 1 chapter she left. Most of the questions, majority of questions asked from the leftover chapter. So what is the probability of scoring full? Is it most likely she can score full or less likely she can score full?
Can score above average. I mean, like,
Is it
if it is out of 100, she will definitely score out of greater than
okay? No. That's a test happens. She prepared, but the clearly instruction was given. The leftover chapter only most of the questions came.
No, ma'am.
But here our question is, what is the probability of getting full score to her? Is it less possibility or more possibility is to get?
They told only one major question, but a major question is asked in chapter that she can prepare.
Only in this case, one major question. Of course, maybe one major question carries many 5 marks. Of course, she left that question. What is the probability of getting full score?
Less.
Full score.
Decreases.
Means
Maybe it depends. Maybe it depends what happens. Maybe half of the question she wrote correct, or else maybe she guesses. I don't know, whatever the things. But we will see that situations, unpredictable things, predictable things. Yes.
What is the difference between chance, probability, and possibility?
Yes, a chance is may happens, may not happens.
Or is chance like There's a chance something which is chosen by somebody.
Suppose rainy season today, if it is rainy season, there is a chance to rain. It is summer season, but these days also, is it a chance to rain? Yes or no? We are experiencing many days classes also cancelled. Is it a chance to happens rain in when summer season also?
Yes, ma'am.
We
That's
cannot
dependent.
tell. We cannot tell when will it come.
Yeah, that's unpredictable things. So we cannot predict exactly true. Coming to the next, suppose if coin tosses 100 times, what is the probability of getting a head all 100 times? Is it more likely you can play this game, children? Take a coin, just toss a coin 100 times, make a record of your 100 times. What is the possibility of getting head? What is the possibility of getting a tail? You can place practically you can. Is it all the time? So suppose you are morning you played once 100 times, and afternoon you played 100 times once, and night you played 100 times once. Is it all three cases are same? We can say it's a fixed one. Only head is a probability of getting head is only the possibility is high.
No, ma'am, we can't.
No, we cannot predict. We cannot predict. That's depending on situation.
Yes, ma'am.
Now, everyone knows that particular train runs in time, but the day you reach well in time, it is late. Everyone knows that particular train runs in time, but the day you reach well in time, it is late.
Yes, ma'am.
What we can in this example, particularly you see, everyone knows because we are giving some ratings, the train ratings, because it comes in time. Most comes in time. Rating is good. The day you reach well in time, it is late. But why it is late?
Ma'am, because he came early.
That's unpredicted. That's not exactly what. Yes, that's unpredicted. Once again, there are many chances. You see, there are multiple examples here, children. You face a lot of situations such as where you take a chance and it does not go the way you want it to go. The best example, the above one. Many situations. So you take a chance and it does not go in the way you want to do. Can please, you can guess some more examples. There are many examples where the chances of certain things happening or not happening are not equal. The chances of train being in time or being late are not the same. When you buy a ticket which is waitlisted, you do take chance. You hope that it might get confirmed by the time you travel. See, there are few more examples here they gave children. So here chances, there is a chance. What chance also there are again three conditions. It depends on three. So you can see some example. The chances of train being in time or chances of being train late are not the same. Maybe someday train is only cancelled. It's not the chances all the time same, right? When you buy a ticket which is waitlisted, you do take a chance. You hope that it might get confirmed by the time you travel. That's only we are hoping. Yes or no? We are just hoping.
Yes,
Maybe
ma'am.
probability of getting confirmation of my ticket is confirmed when I'm traveling, when the time of traveling. That is only the chance, probability, maybe probability. We are may not, may not, or it may happens or may not happens. There is a chance. No chance. That's many things. You can see the multiple examples here. However, consider here certain experiments whose results have equal chance of occurring. There is a few examples, a few experiments. Those results have an equal chance of occurring. Equal chance, maybe success or whatever. There is equal chance here. What are those we can see? You might have seen that before cricket match starts, captain of two teams go out, toss a coin to decide which team will be first, bat first. So in that, what they're tossing a coin, yes or no, children? That depends on which team will be bat first, which team will be bowling first. That's depending on the tossing of the coin. What is the possible result you got when a coin is tossed? Of course, maybe it is a coin means obviously there is only two chances. One is head or maybe
Head.
another chance is tail. Imagine that you are a captain of one team and your friend is captain of other team. You toss a coin and ask your friend to make the call.
Okay, ma'am.
Yes. Can you control the result of the toss? Is it possible to control the result of toss?
No, ma'am.
Can you get ahead if you want one?
What, ma'am?
No, ma'am.
See, there are multiple questions, children. These are the favorable questions. So you can see. What is the question here? You toss a coin, ask your friend to make the call. Can you control the result of the toss? That's first thing. Second one, can you get ahead if you want one or tail? Or if you want that, no, that is not possible. Such experiment is called a random experiments. Head or tail are the two outcomes of an experiment. Here, there is a two possibilities, two chances. Maybe head happens or tail happens. Such experiments, we can call it as equal chances. If you see either head or tail, maybe your friend is batting means you are bowling, or your batting means your friend is. That means what is the chance here? Exactly. What is the chance here? Half of the chance. Yes or no?
Yes, ma'am.
So that's why in such experiments we can call it as a random experiments.
Unexpected experiment.
That means equal chances. Your friend may bat or you may bat. That's equal chances.
Yes, ma'am.
There is an equal chance of occurring here. Coming to, there are a few more try these questions are given. If you try to start a scooter, what are possible outcomes? If you try to start a scooter, what are the possible outcomes? Think and let me know, children. Yes.
Ma'am, it may start, it may not start.
If you start a scooter, what are the possible outcomes? Yes. When a die is thrown, what are 6 possible outcomes? If you try to start a scooter, what are the possible outcomes? Yes, Hari Karthik. Die means obviously we know that there are 6 possible outcomes, 1, 2, 6. So sometimes you may get 1, sometimes you may get 2, or 3, 4, 5, 6. These are the possible outcomes. So coming to, if you start a scooter, what is the possible outcomes?
And would
Scooter
either
is
start
going to...
or would fail to start.
Yes, that's our only, yeah. Coming to the second one, it's we know that what are the possible, die is thrown. What are 6 possible outcomes means? Maybe 1, maybe 2, maybe 3, maybe 4, or maybe 5 or 6. Now coming to see the situations, children. Okay, observe the situation. When you spin a wheel, there is a wheel here. You see there is a marking of A, B, C sectors. Other wheel is there. What are the possible outcomes? List. What are the possible outcomes?
Ma'am, also at
A,
A
B, and
and B and C.
Yeah. Is it possible outcome as a D? What is the possible outcome as a D?
0.
0. 0. Very good. What is possible outcome for getting A?
1 by 3.
1
1 by 3.
1 by 3.
What is? Yes. Why it is D as 0? Because there is no.
Because there is no D.
Yeah, no D here. Only 3 chances. 3 sectors it is divided. Maybe it is A. Pointer maybe on A, on B, or on C. These are only 3 possibilities. The outcome here means the scooter at which the point, okay, the sector at which the pointer stops. Okay. There are only 3 outcomes, children. One is A, maybe possibility of getting A, possibility of getting B, or possibility of getting C. The second example, if you see, what is possibility of getting a white? There are different marbles or coins. You can take white, red, blue,
1 by
green,
5.
yellow.
1 by 5.
So what we can say?
1 by 5.
1 by 5. Very good. So here, not suppose here white, red, blue, green, yellow. There are only 5 colors. Suppose rather than this, any other color, they're asking what is the probability of getting what other color we can see here? No color. Yellow is there, green, red, blue, violet. What is the possibility of getting violet color?
0.
0.
0.
Right. What is possibility of getting white marble?
1 by 5.
What is possibility of getting white marble as well as red marble?
2 by 5.
2 by 5.
Right? Maybe
Yes.
there are multiple questions you can. You have a bag of 5 identical balls in colored put a ball without looking at list outcomes you would get. Okay, without taking any no color choice. So just pick up a ball means it's 1 by 5. Think, discuss, and write. In throwing a die, does the first player have greater chance of getting a 6? In throwing a die, this is one practical. You have a die means you can take children. Does a first player having greater chance of getting a 6?
It may or not be, ma'am.
May or may not. Is it any confirmation, ma'am? Surely the first
No, ma'am.
child get
Oh, ma'am.
6.
Not that.
No.
May or may not. Next, second situation, if you see, would the player who played after him have lesser chance of getting 6?
No, ma'am.
No,
Would
ma'am.
the
No,
player
ma'am.
who played after him have lesser chance of getting 6?
No, ma'am.
No, ma'am.
No, very good. Suppose the second player got 6. Does it mean the third player would not have a chance of getting 6?
No.
No, ma'am.
No, no.
No.
No, it's not unpredictable. These are not exactly, it happens. The earlier case, the coin
But
toss
sometimes
maybe
it happens.
sometimes maybe it's unpredictable. Children, we cannot predict some situations, right? Equally likely outcomes. If you see equally likely outcome, what is the meaning of equally likely outcome? It's more important. The words terminology is more important, children. Equally likely outcome means a coin tossed several times and the number of times we got head or tail is noted. Let us look the result sheet where we kept increasing the tosses. So you see here, they gave us a number of tosses 50 times. In 50 times, what is the possibility of getting head, children? You can see count the tallies 5, 10, 15, 20, 25, 26, 27, right?
Yes,
So
ma'am.
number of heads possible 27 chances. The rest means the rest of the part out of 20, 50, 27 if you subtract what is left over 23, right?
Yes, ma'am.
23. Suppose the number of tosses 60 if you take, and this is just random experiment, children. It's not exactly what it's a random experiment. They gave for best example was 60 times if a coin tossed, 20, 25, 28 times the number heads and 32 times the tails happening. 70 times if you take, 70 times if you toss a coin, 70, several times, 70 times. So what is the number of times we get as a head, children? 33 times. And number of tail is 37. Same way, if you extend the number of times the experiment, if you increases, 80 times means 38 and 42, 90 times means 44 and 46, and 100 times means 48 and 52. From this, what you can observe, you increase the number of times more and more. What happening? The number of head and the number of tail outcomes closer to each other. Yes or no? If you look here, earlier first it's 27 and 23, then 28 and 32, 33 and 37, 38, 42, 44, 46, then 48 and 52, 48 and 52. That means what is your observation, children? It is very closure. It's very closure. If you increase number of times, the number of experiment, number of times if you place a coin, almost maybe equal chances, children. That's almost equal. It's not exactly equal, almost equal. That's why they use the word equally likely outcome. The word is equally likely outcome. It's not exact. It's equally likely outcome. That's why observe that times increase, the number of tosses more and more, the number of heads and number of tail comes closer and closer to each other. This could also be done with a die. What tossed a large number of times. So when tossed a large number of times, number of each of 6 outcomes becomes almost equal to each other. In such cases, we may say that different outcomes of experiments are equally likely. Number of times increases. What happening, children? Outcomes of an experiment are equally likely. That's more important. Outcomes of an experiment. So when, in which case it happens? In which case it happens? If you increase the number of tosses more and more, yes, what happening in this case? Tails comes closer and closer to each other. Suppose if same thing if you done with a die, that means increase the number of times playing with tossing a die. What happened? When you toss large number of times, number of each 6 outcomes become almost equal to each other. Yeah. The second, another case, if you see, different outcomes of an experiment are equally likely. In all cases, we can say number of experiments we are doing many times means multiple times. We are continuously, repeatedly doing that experiment. What happens? There is a probability of getting chances are equally likely. Equally likely. Suppose one day you are playing cricket match. Because of rain, you cancelled. Again, second day you are playing a game. What is again, game is cancelled. Again, third day you are playing. What is the number of times? Multiple times. If you are same thing repeated means what happened? What is the probability of getting winning a chance for the team?
Ma'am, nothing.
How no, children, statistical people can be experiment multiple times. Maybe there is a probability of chance. There is a chance of winning the team means because they are randomly they can experiment multiple areas based on players, based on weather conditions, based on what playing playground. Playground means whatever the players are playing area, ground area, and something sometimes the pitch something I don't know whatever. Multiple random experiments they're taking. Then they're They are predicting whether maybe chances of winning this team.
So if you could predict the last number, then the chance, like, then there would last number, there would be half heads and half tails, right?
That is equally likely.
Okay.
Equally
No,
likely.
ma'am,
That's
if you could imagine the last number as something, and if you throw that many times, like if you toss a coin that many times, then the chance of heads and tails would be 50-50 now.
50-50. Absolutely correct. Yes, correct. Exactly equal 50-50 chances. Coming to the part of next thing, these are only the word why they gave here. Equally likely outcomes when it happens means if you multiple times repeatedly, if you happen to increase the number of tosses or increase the number of times an experiment, the chances will be equally likely. The chances will be equally likely. This means that each of outcomes has the same chance of occurring. That means you and your partner both having the equal chances of winning. Okay. Yes. So Pranav, what is here? There is a coin here. You can see on the board. I could fall like this. What is the meaning of this? You can see here. There is a coin. It's not a tail. It's not head. What's happening here? You see the coin, position of the coin. You see the position of the die. What is that? That case, how are you supposed to assess that case?
Ma'am, there are no chances for it.
Suppose the coin is fall like that. There is no head, no tail.
Yes, ma'am.
What is some other experiment? Can you please?
Ma'am, we can take a rock. Ma'am, we can take a rock and paint some area, and we can say it,
Yes,
your
ma'am.
team is this, and my team is the other side. You can use it that.
Okay, sometimes the rock is not either side. It is falling like a coin, how it is shown in picture.
Yes, ma'am. Ma'am, but we can use it, right? Without coin.
You see, there is something they written on that. What is that? I could fall like this or get lost. Okay, that means get lost. Okay, I could land like this against this wall. Oh, do not worry, such cases will not be considered as the possibility is very small. We are not, what happening in that cases?
We are not worrying.
No, we are not going to consider that.
Okay,
Not at all considered. Cancelling. We cancelled that. Suppose you are placing tossing a coin. The coin is standing like that position. So that experiment you can cancel.
Yes, ma'am.
Don't consider that.
Okay.
Because the possibility is very small there. There is nothing, no possibility as a head or tail. Okay. Next, coming to the what is equally likely. The keyword from this all points, you can know this is equally likely means multiple times. If you do an experiment, what happened? What is the outcome? It is equally likely outcomes. Okay. Next, this case we are not considering. Linking chances to probability. How it links chance to probability. Then now just before Hari Karthik is asked, ma'am, is it any differences chance probability? You see how we supposed to link this to chances to probability. Consider the experiment of tossing coin once. What are the outcomes, children? If you toss a coin once, what are the possible outcomes?
It may come.
There are only two outcomes, head or tail. Both outcomes are equally likely. Just before, as we mentioned, equally likely.
Okay.
likelihood of getting head.
One
Head
by-
is one out of the two outcomes. That means half of chance. In words, we can
By-
say the probability of getting head is
1 by
half.
2.
How we are connecting the word chance to probability, you see, children? We are doing experiment. In that experiment, outcomes are either head or tail. Both the outcomes are equally likely. Likelihood of getting a head is 1 by 2. In other way, we can say the probability of getting head. In other way, probability of getting head is 1 by 2. What is probability of getting tail? Same thing, because equally likely, right? Chance is equally likely. Now you take an example throwing a die marked 1 to 6 on the faces. If you throw it once, what outcomes may happen? Maybe outcomes either 1 or 2 or 3 or 4 or 5, 6. The 6 equally likely outcomes. What is the probability of getting 2? What is the probability of getting 1? 1 by 6. 2 means 2 by 6. 3 means, 2 also 1 by 6. There are, so not number, we cannot consider number, children. You see very carefully, you see. What is the probability of getting probability of getting 2? Out of, what are the total number of possibilities? Maybe 1, maybe 2, maybe 3, maybe 4, 5, 6. Total possibilities are 6. In the among that, which one is favorable? Which one you are considering? Your outcome as 2. Your outcome as 2. 2, how many times is it possible to get? Only one time. Out of 6, 2 can occurs only one time. So 1 by 6. It's 1 by 6. That's why number of outcomes is given. Total equally likely outcomes are 6. What is the probability of getting number 5? It's also 1 by 6. What is the probability of getting number 7? Number 7.
Ma'am,
What is the
0.
probability of getting number 7 when you throw your dice? When you
Ma'am,
toss a
0.
dice,
Ma'am,
what
0.
is the probability of getting 7?
0, ma'am.
0. Because dice has 1 to 6. There is no 7. That's why it is 0. What is the probability of getting number 1 through 6? Only each one 1 by 6, 1 by 6. Outcomes as events. Outcomes as events. Chances as probability. Here outcomes as events. Each outcome of an experiment. Outcome means result, children. Each result of an experiment or collection of outcomes makes an event. So what is event? Event, the examples definition is more important, children. Each outcome of an experiment or collection of outcomes make an event. Collection of outcomes makes an event. In an experiment, tossing coin, getting head is an event and getting tail is an event. Yes? What are the outcomes? Outcomes is only events, children. So what is
Yes,
suppose
ma'am.
a coin? Coin means tossing means head
Ma'am?
is an event. Tail is also an event.
Yes, ma'am.
In
Heads
case
also,
of
ma'am?
throwing, yes, ma'am.
Okay, ma'am.
In case of throwing a die, getting each outcomes 1 to 6.
Yes, ma'am.
What is the possibility here getting even number? So see, children, these are multiple questions on dice. You may get probably. What are even numbers? Possibility of getting even numbers. What are even numbers here? 2, 4, 6. 2, 4, 6. How many
Yes, ma'am.
events? How many events? How many outcomes? Possible outcomes.
Ma'am, it is uncountable. We
Hey,
can't.
2 even numbers. A probability of
Yes,
getting
ma'am.
even number.
Ma'am, by
Ma'am, it's
No.
3 by 6 or 1 by
3
6.
possibilities, right? Out of total 6.
ma'am, we
Total 6.
mostly can get 3, 5,
No,
or 4.
exactly, because 2, 4, 6 are even numbers.
Yes, ma'am. We can only get 3, 5. 1 is rare, ma'am. 1
3
is
out
rare.
of 6. 3 out of 6 means half of chance. Possibility of
Yes,
getting
ma'am.
even number is half of chance.
Half of chance, ma'am. But sometimes we can also get 6 many times.
No, possibility of getting prime numbers.
Not prime, ma'am. 6 even numbers only. We can sometimes get many times
No,
6.
Sriram, you listen here. Probability of getting prime numbers. My question is prime numbers. What are prime
Yes,
numbers
ma'am.
among 6? 1 to
Ma'am,
6, what are prime
135.
number?
Ma'am,
Three.
135.
1 is prime number.
Oh, ma'am, it's
Oh, ma'am, sorry, 35.
3, 5.
Two,
What
three.
about hey, what are prime numbers?
Ma'am, it will divisible by itself and 1,
Yes,
ma'am.
ma'am.
Very
And
good. Then what? How many prime numbers you have here?
3.
ma'am, 2.
Hey, again, who is that 2?
Ma'am, 2, 3, 5, ma'am, 3.
There are 3 prime numbers. That means
Oh.
3 outcomes, 3 possibilities out
Okay,
of
ma'am.
6. That's
Oh,
again
yes.
half of.
Oh, okay.
Like that,
Okay.
multiple questions you may get, children. They
Got
in
it,
the
ma'am.
same concept. When your die is thrown, what is the probability of getting 1? What is the probability of getting 2? That may, or else what is the probability of getting even number? What is the probability of getting odd numbers? What is the probability of getting even prime number?
Even prime number is 2.
That means what is the probability of getting even prime number? Probability is nothing but favorable things divided by total number of outcomes. Favorable outcomes divided by total outcomes. Favorable is only 2 divided by, that means not a number 2. That's only one chance. One time you may get. That's 1 divided by out of 6. 1 by 6.
Yes, ma'am.
There is a bag, children, in this 4 red, 2 yellow balls. The balls are identical in all respective then color. The ball is drawn from bag without looking into the bag. What is the probability of getting a red ball? Okay. How many red balls? 4 balls, 2 yellows. You go with some practical, children. Theory part, it's a continuous theory makes you. Suppose you can take this is a bag. In this bag, what they mentioned, how many reds and how many yellows, ma?
Ma'am, 4 red balls and 2 yellow balls.
Yes. 4 reds and all are equal in size. Don't think different, children. Maybe sometimes yeah, you cannot. Same like 4 identical. Identical means the same. Oh, sorry. Two yellow. Now you can see what is the probability of getting a yellow ball among these children. What is the probability of getting a yellow ball?
2 by 6.
If you pick randomly, if you do randomly without seeing any coin from the bag, if you take randomly, what is the probability of getting the coin should be yellow? Yes. Total outcomes. You have to write a total. Total, how many outcomes you have, children?
6 outcomes.
Total outcomes, how many are there here? 4
4
plus 2.
6.
4 plus 2,
4
which
plus
is
2.
6.
6.
What is yellow? Maybe it is possibility of getting yellow. Or
Yes.
probability of getting yellow. Yellow, how many you have, children?
2.
2.
2. Yes. That means favorable outcomes.
2 by 6.
Favorable outcomes 2.
2.
So if you want probability, if you want probability of getting either yellow, probability of getting yellow means there are 1, 2 chances.
2 by
Yes or
6.
no? Out of 6, 2
2 by
chances.
1 by 3.
Or 1 by
1
3.
by 3. Suppose probability of getting red.
4 by 6 or 2 by 3.
4 by 6 or
4 by 6.
2 by
2
3.
by
2 by 3. 2 by 3. That means what is the probability, children? Probability is nothing but favorable outcomes. Favorable outcomes. So whatever the question they're asking, favorable outcomes divided by total
number of
Outcomes.
yes, number of outcomes. Based on this,
Yes, ma'am.
complete. Only this formula we are using the complete chapter, children.
Yes, ma'am.
There is once again the wheel question is occurring. You can see, oh, there is another question. Okay, no, same thing. I've done like suppose a spin on the wheel, list number of outcomes getting green sector. How many greens are there, please, first, children? How many possible greens are there?
5, ma'am.
5.
5. Total
5.
sectors. How many total sectors?
8.
8.
8.
8. So what is the
5 by 8.
probability of getting a green sector?
5 by 8.
5 by
5 by
8.
8. 5 by 8.
Very good. And not getting a green sector?
3 by
3 by
5.
8. 3 by 8.
Very good.
3 by
3
8.
by 8. So if you combine getting a green and not getting green together, you will get a whole, right? That's one thing, children. Probability always lies between less than 1. Probability always less than 1. That's
1.
more important thing you need to remember. It is not more than 1. If you are getting anywhere probability as more than 1, then you are doing wrong. So probability lies between 0 and 1.
Okay, ma'am.
Next, chance and probability related to day-to-day life situations. Same thing. Okay. Directly we'll go with the exercise substitute. Okay. List outcomes you can see in this experiment, spinning the wheel. List outcomes, only outcomes. They're asking about what are the outcomes?
Ma'am, there are 4 outcomes. A, B, C.
Ma'am, there are 4 outcomes.
Ma'am, 5 marks. Ma'am, 5 marks.
What are 5? Please let me know.
It's just 4. A is 2 times, so it is counted as 1. B, C, D is just 1, so it's 4.
Spinning a wheel outcomes. Maybe a probability of getting A or B or C or D. 4 outcomes, children. Tossing
Yes,
2
ma'am.
coins together. Tossing 2 coins together. If you take 2 coins,
We might
together,
get A and B.
No. I'm not asking. This is another. You are taking 2 coins together. 2 coins together. So what is
Okay,
the
ma'am.
probability of getting possible outcomes? Possible outcomes.
2.
Maybe head. Yes or no? Head.
Yes, ma'am.
Maybe tail. And in first coin head and second coin tail. And in first coin tail and second coin
Head.
head. Now, how many possible outcomes we are
4.
getting?
4.
4.
Four possible outcomes. If 2 coins are tossed together, the possible outcomes are head,
Four.
tail, head, tail. 4 outcomes. Spinning
Yes,
wheel
ma'am.
means
Ma'am, we might get anything.
A, B, C, D. When a die thrown, list outcomes of an event of getting a prime number. Just now we read, children, prime numbers. There are 3 possibilities.
2,
3 by
3,
6.
5.
5.
2, 3, 5.
Children, 2, 3, 5. Correct one. 2, 3, 5 means 3 outcomes.
Yes, ma'am.
Out of 6, 3 outcomes means half of chance.
Yes, ma'am.
Ma'am, it's just asking the outcomes in question number 6. It's
Next.
probability.
Not a prime number.
Not a prime number. So it's even number.
Yeah, not a prime number means
Even number.
maybe 1, maybe 4,
One,
maybe 6.
1 to 6.
1, 4, 6.
Yes, ma'am.
Oh, sorry, 1 4 6. 1 4 6.
3 out of 6. That means 3 by 6 means half of chance.
Yes, ma'am. Half
A
of
number,
chance.
a number greater than 5.
Ma'am, 6.
6. 1. 6.
Yes, only one chance. Very
Yes,
good.
ma'am.
1
It
by
is only
6.
one chance.
1 by 6. A number greater than 5.
Not greater than, ma'am. Not
Not
greater.
greater than.
Ma'am,
Not
4.
greater than 5. 4. 4 out of
4 out of
6.
6.
2 by 3, right?
Yes, ma'am.
Find the probability of the yes. Find the probability of pointer spinning on D in question number 1A. So probability of D. What is the probability of D, children? Only one chance out of?
Only one chance.
Out of?
Can't say.
5.
Many.
Out of 5 or 4?
Ma'am, 4, ma'am. Ma'am, it's
Total
4.
outcomes.
Ma'am, it's 4.
What
2
are
is 4.
total outcomes in this case?
Ma'am, they are just 4, ma'am. BCDs are singular. A and A is just double, ma'am. Which actually it is just
Now my
A.
question, you see the question here. Probability of a pointer stopping on D. So only one out
Ma'am,
of.
it's 1.
Out of
5.
5.
5 children, we cannot consider 4
Why?
because that's the different sectors. It is divided into different sectors, right?
Yes.
Next, what is probability of getting an ace from well shuffled deck of 52 playing cards? That's more important, children. Cards. If you see the cards, just 1 minute, children. I'll show it so that it's more easy for you to remember.
Okay, ma'am.
How many cards you have, children? Holidays, you people can enjoy with your cards too, right?
Yes, ma'am.
Ma'am, what did you say?
Pack of cards.
Okay, ma'am. Ma'am, when will the holidays begin?
Maybe children, I was not available in the month of June and June last week and July. So we can little faster with our things.
Okay.
How the distribution means yes cards. How many gram? 52. Out of 52, a pack of cards means out of 52. What we have, children? How many red cards? How many black cards? In red cards, we have diamonds and hearts, right? Spades and what is in black cards, children? Anyone knows about cards?
No, ma'am.
Ma'am, no, ma'am, I don't know. I'm new.
No, ma'am.
Okay, there are how many black cards and how many red cards? I'll just show. There are total 52 cards. In that black card, half of black. That means 26, right?
Yes,
and
ma'am.
red, in red, there is a heart shape and as well as diamond shape. 1 minute, children. How many cards? Spades. Right. Are you able to see the cards?
No, ma'am.
Cards.
No, ma'am, we can't see the notes. You did
1
not
minute.
share the screen.
Yeah. Chapter is only little the theory part, children. Sounds very easy. Probability questions you can score full.
Okay, ma'am. Did you share?
Yeah. 1 minute, children. I'll share my screen so you can see and remember the things. You can see, children, among the 52 cards, how many total we have 52 cards. In that we have black cards 26 and red cards 26. In black cards we have spades 13 and clubs 13. So in spades you have one king, club you have, that means two kings, two queens, two jacks, two aces.
2 to 10 cards.
2 to 10 cards, total together 13 cards. Total 13 plus 13, 26. Diamond and hearts also same thing, children. 2 kings, 2 queens, 2 jacks, 2 aces, and 2 to 10 cards, total 26. So this is the, if you want, you can please make a note this so that it is easy for you.
Another game like this, ma'am. Uno.
Card games we are playing, right? Children, in summer holidays, everyone can play this. I think people, I don't know how much.
Ma'am, our parents don't allow us to play these.
It's not such a, you're not taking money for the money and all those things, and they don't tell you something. Only you need to know the what are the different cards.
The other version of
how many spades you have, how many clubs you have, how many diamonds you have, how many hearts you have. Total 3 13s. Among 3 13s, what are the different number? How many number cards? How many picture cards? That's also more important, children. There are 8 picture cards and 8 picture cards, and the rest of the cards as number cards.
Yes, ma'am. Ma'am, like that, there is another one, ma'am. You know.
They may ask you whatever the question regarding the question you see here. Question is, okay, find the probability of, this is done, right? Where we which question we completed? Children, please
B, ma'am.
Yeah, you can please try, children, about the cards you go through and come back, children. We'll see in next class the rest of the part.
Okay, ma'am.
Okay. Bye, children.
Okay, ma'am. Bye, ma'am. Good night, ma'am.
Bye, ma'am.
Bye, children. Bye. Bye, Harish.
Bye, ma'am.